Okay, let's just write down everything we know. We know that the period is equal to 25.0 times 10 to the minus 3 seconds. So this effectively tells us omega. Omega is equal to 2 pi f, which is 2 pi on t. So this tells us that omega is equal to 2 pi over 25.0 times 10 to the minus 3, which is equal to 80 pi. Okay, now we're told it's moving in the negative direction, and we're told that the velocity is equal to 30.0 meters per second. We're told at t equals 0 and x equals 0, then y is equal to 2.00 centimeters, that's 0.0200 meters, and that the velocity, the transverse velocity Vy, is equal to 2.00 meters per second downwards. So let's make that minus 2.00 meters per second. Okay, so we've got the wave equation of the form y of xt is equal to a sine, now kx, now because it's moving in the negative direction, we've got a plus omega t plus phi. So we've worked out what omega is. Let's see if we can work out what k is. K is equal to 2 pi over lambda, and lambda is equal to v over f. Okay, now the velocity is 30. The frequency is the inverse of the period, so this is 25.0 times 10 to the minus 3, and so this is equal to 0.75. And so k is equal to 2 pi over 0.75, so that's 2 2/3 pi. Okay, so we've got y of xt is equal to a sine 2 2/3 x plus 80, sorry there's a pi, 80 pi t plus phi. And we know this information, so that tells us that 0.0200 is equal to a sine phi. But there's two unknowns there, we don't know a and we don't know phi. So what we need to do now is make use of this piece of information, so we'll need to differentiate this. So dy dt is equal to Vy, which is this thing. So taking the derivative of this, we end up with 80a times 80 pi cos 2 2/3 pi x plus 80 pi t plus phi. And so using this, we've got minus 2.00 is equal to 80 pi a cos phi. Okay, now let's start by finding the phase angle, which is actually part B. Let's call this 1 and let's call this 2. If we do 1 over 2, we end up with a sine phi over 80 pi a cos phi is equal to 0.0200 over minus 2.00, and these a's cancel out and this becomes a tan. So we have tan phi is equal to 0.0200 over minus 2.00 times 80 pi. And solving that on the calculator for inverse tan, we end up with phi is equal to minus 1.19 radians. Okay, so this is a negative angle and it comes from tan, so it's in this second quadrant here. So if instead of a negative we want it as a positive, we can also do phi is equal to pi minus 1.19, which gives us 1.95 radians. So that's our phase angle. Now what we need to do is find the amplitude, so that's part B. To get the amplitude, what we can do is, let's just rearrange this. Let's put this over the bottom here. Now if we do 1 squared plus 2 squared, we'll have a squared outside of sine squared phi plus cos squared phi is equal to 0.02 squared plus minus 2.00 over 80 pi all squared, and this is equal to 1, and so a squared is equal to this plus this. And so solving that on the calculator, we actually end up with a is equal to 0.0215 meters. If we wanted, we could have just substituted phi into here to get that amplitude as well. There's a couple of ways to do it. So that's our answer to A. Now part C said what's the maximum transverse speed? Well, we've figured out our equation here for the transverse speed. So all we need to do now is work out what's the maximum of that. Well, that's going to happen when this thing is 1. So it'll be A times 80 pi. And so just substituting in for A, we get 5.40 meters per second. And then D is just asking us to write out the wave equation. So I've written it out here. We just need to here's our latest version. We just need to substitute in all our values. So y of xt is equal to 0.0215 sine 2 2/3 pi x plus 80 pi t plus 1.95. And there we go. That's our wave equation, and that's the end of this lecture series.